Okay, so the first question is, given that the tangent line to the graph of y equals g of x at the point 4, 5 passes through the point 7, 0, find g of 4 and g prime of 5. So the key idea here is that when you have the tangent line to a function at a point, it gives you a point on the graph and the slope at the point. So the point on the graph, we're looking for the y-coordinate, is g of 4. And g of 4 has to be 5. Because the tangent line to the graph is 4, 5. So they share the same point, and it's 4, 5. So g of 4 has to be 5. Now the only thing we need is the slope, and that is g prime of 4. The derivative is the slope. The g prime of 4 is the derivative at 4, and all that is the slope of the tangent line. Now we were given 2 points that this tangent line goes through, and so now we can find that slope. It's y2 minus y1 over x2 minus x1, where in this case, it doesn't matter which order we take, x1 is 4, y1 is 5, x2 is 7, y2 is 0. 0 minus 5 over 7 minus 4. The slope is negative 5 over 3. That is g prime of 4. Given that y equals negative 2x plus 4 is tangent to y equals f of x, determine a tangent line to y equals h of x plus 2. Now, h of x plus 2 is a function, and it is just h of x shifted 2 units left. The key idea here is that shifting a tangent line to a function is the same as the function keeps, shifting a tangent line to a function the same as the function keeps the tangent line to the graph. So that means that if you have a line that's tangent to a function and you shift the function 2 units to the left, then you can keep a tangent line just by shifting the tangent line you currently have to the left as well. And so if y equals negative 2x plus 4 is tangent to h of x, then shifting y equals minus 2x plus 4 2 units left will be tangent to h of x plus 2. That means that we're interested in the new line y equals minus 2 times x plus 2 plus 4. Distribute minus 2x minus 4 plus 4. Y equals negative 2x is tangent to h of x plus 2. Given that y equals 4x minus 7 is tangent to y equals f of x, and f of x is invertible, determine a tangent line to y equals f inverse of x. The key idea is that if a tangent line closely approximates a function that is invertible, then the inverse of the tangent line is tangent to the inverse function. That is to say that if this line is close to f of x, then the inverse of this line should be close to the inverse of f of x, and therefore to find the tangent line to the inverse, f inverse of x. Find the inverse of the tangent line. Well, we know the steps to finding an inverse. 1, you let y equal the function, 4x minus 7. 2, you switch the x's and y's. And so x equals 4y minus 7. And then step 3 is you solve for y. Right? So then we've got x equals 4y minus 7. We'll add 7 to both sides. X plus 7 equals 4y. And then we'll divide both sides by 4. Y equals x plus 7 over 4, or x over 4 plus 7 over 4. Determine C so that for f of x equal to x squared, the average rate of change between A and B equals the instantaneous rate of change at C. We'll do some translating. The instantaneous range of C is called the derivative at C. The average rate of change from A to B is f of B minus f of A over B minus A. We'll translate this. Determine C so that f prime of C is equal to f of B minus f of A over B minus A. And we'll simply calculate each one of these things. So f of x is x squared. F of B is b squared. F of A is a squared. F prime of x is the derivative, that is 2x. F prime of C is 2c. F prime of C equals f of B minus f of A over B minus A. Let's do some simplifying here. F prime of C we've already written. It's 2c. F of B minus f of A over B minus A. F of B is b squared minus f of A is a squared. B minus A. This means that 2c equals, and we are going to factor the b squared minus a squared. That's b minus a times b plus a all over b minus a. The b minus a's cancel. That leaves us with 2c equals the b minus a's left around, and then we'll divide both sides by c. C is equal to, divide both sides by 2. C is equal to 1/2 b plus a. Find the instantaneous rate of change for y equals this. This means find the derivative. We're going to do some simplifying first. We got y equals sine x minus cosine x squared plus the sine of 2x. We're going to go ahead and square this. This means we got sine x minus cosine x. We're going to raise it to the second power, which means we're going to multiply it times itself. We're going to FOIL out. So sine x times sine x is sine squared x. Sine x times minus cosine x is minus sine x cosine x. We've got a negative cosine x times a sine x, and that gives us another minus sine x cosine x. And then finally, we've got a cosine x times another cosine x, and they're both negative, so that's plus cosine squared x. And then this sine 2x just stays there. When we simplify, we have sine squared x, and then I got minus one of these and another minus one of those. That makes minus 2 of those. plus cosine squared x. And then all we're going to do is rearrange a little bit. Let's put equal signs here. Equals. This is then equal to, we're going to write this, sine squared x plus cosine squared x. We'll group those together. And then minus 2 sine x cosine x plus the sine of 2x. And then we'll just look at our remark here that the sine of 2x is equal to 2 sine x cosine x, so they cancel. And I didn't write this here, but sine squared x plus cosine squared x is always 1 for any x. So this is 1, and then we can substitute this in. We can write this like this, minus sine 2x plus sine 2x. And so this is 1. All of this was just to say that y, no matter how ugly it looked initially, it's just 1 for every x. So it's pretty easy to take the derivative. The derivative of y is 0 for every x. And specifically, when x is 2 pi over 3, y prime is 0 there. The answer is 0. Find the value a so that the tangent line to y equals 1 over the square root of x at x equals a is parallel to the line y equals negative 4x. The key idea is that the slope of the tangent line is the derivative, and two lines are parallel if the slopes of each are equal. That means all this is translating is saying find a such that the derivative at a is equal to negative 4. We're going to take the derivative of y and set it equal to negative 4 because we want the tangent line, we want to have the same slope as this line, right? So we want the slope of the tangent line to be the same as the slope of this line. But the slope of the tangent line is the derivative, so we want the derivative to be the same as the slope of this line. We want the derivative to be negative 4. 1 over the square root of x, I'm going to rewrite that as 1 over x to the 1/2, which is x to the negative 1/2. And I'm writing it like this so that I can apply the power rule. So that y prime is equal to minus 1/2 x to the minus 3/2. Subtract 1 from the power. So we'll bring the minus 1/2 down, subtract 1 from the power, and so now we want to set that equal to negative 4. So minus 1/2 x to the minus 3/2 is equal to negative 4. And so one of the things I want to do is I want to go ahead and multiply both sides by negative 2. So x to the minus 3 over 2 equals 8. And then rewrite this. This is 1 over x to the 3/2 equals 8. This means that flipping both sides, x to the 3/2 equals 1 over 8. And so this means that x is equal to 1 over 8 to the 2/3. Well, this is equal to 1 to the 2/3 is 1, and then 8 to the 2/3 is equal to 4. And the reason is because 8 to the 2/3 is equal to the third root of 8 squared. And the number that you raise to the third power to get 8 is 2. So this is 2 squared, which is 4. The answer is 1 over 4. That's what A should be. Find all lines of the form y equals kx which are tangent to the curve y equals x squared minus 3x plus 4. The key idea here is that tangent lines to a function share a point and a slope. So here we have a tangent line y equals kx, and here we have the graph y equals x squared minus 3x plus 4. And if we want them to be tangent, that means they share a point. And so that means that they must intersect. That means that they have to be equal. So kx equals x squared minus 3x plus 4 wherever they are tangent. Here also, if it's tangent, they have to share a slope. That means that they have the same slope. But the slope of y equals kx is k, and the slope of y equals x squared minus 3x plus 4 is just the derivative. It's 2x minus 3. So here are two equations with two unknowns, k and x, and all we're going to do is use the substitution method. We're going to take this k and we're going to substitute it in for k here. That will give us an equation involving only x, and then we'll have what x is, and then we can do what we need to do. Putting this in, 2x minus 3 times x equals x squared minus 3x plus 4. 2x squared minus 3x equals x squared minus 3x plus 4. From this we get that, subtracting x squared on both sides, x squared equals 4. And so x equals 2, or x equals negative 2. And we just have to remember this very nice relationship between k and x. Since we know that k is equal to 2x minus 3, when x is 2, then k equals 2 times 2 minus 3. K is 1. When x is negative 2, then k equals 2 times negative 2 minus 3, and k is equal to negative 7. The two answers are y equals 1x and y equals negative 7x. Find another tangent line to f of x equals 1 over x, which is parallel to the tangent line to f of x at x equals 2. So the function is f of x equals 1 over x, and I'm looking for another place where another tangent line that is parallel to here. Well, let's find the tangent line, at least the slope, at 2. We need the derivative. It's f prime of x. So remember that this is x to the minus 1. So f prime of x is minus x to the minus 2, which is negative 1 over x squared. If we want a tangent line that's parallel to the tangent line at 2, then we need to know the slope there. So f prime of 2 is the slope there. It's minus 1 over 2 squared, and that is negative 1 over 4. So then the question becomes, is there another place? Is there another value where f prime of x is equal to negative 1 over 4, right? But f prime of x is minus 1 over x squared, so minus 1 over x squared is equal to negative 1 over 4. When flip both sides and drop the minus signs, x squared is equal to 4, and it's when x is equal to 2 or x is equal to negative 2. Well, we already had the 2 that was given, and so the other place where the derivative is the same is at negative 2. And so we need the value at negative 2, so f of negative 2 is negative 1 over 2. Let's see if we have everything. I think we do. We have a point and a slope. We want the equation of the tangent line. It's y minus y1 equals m, which is the slope, -1/4 times x minus x1 in this case is -2. Right. y1 we know, y1 is -1/2. It's y plus 1/2 equals -1/4 times x plus 2. Y plus 1/2 equals -1/4 minus x minus -1/4 times 2 is -1/2. Subtract 1/2 from both sides. Y equals -1/4 x minus 1. Some people like to use y equals mx plus b, so you could have done this, y equals -1/4 x plus b, and then just use the point that you have, -2, comma, -1/2, and you would have gotten the same thing. Find a and b so that y equals ax squared plus bx plus 5 is tangent to the line y equals 2x minus 3 at 2, comma 1. We've seen this key idea before, that tangent lines to a function share a point and a slope. If they share a point and they share a slope, that's going to give us two equations and two unknowns. And we have two unknowns, a and b, that we actually need to solve for. So if they share a point, that means that when you plug in 2, you're supposed to get 1. So this means that when you plug in 2 for x, you get y equals 1. So 1 equals a times 2 squared plus b times 2 plus 5. And that is one equation involving a and b. We'll simplify just a little bit. It is 1 equals 4a plus 2b plus 5. We can write this as 4a plus 2b equals -4, subtracting 5 on both sides. They also share a slope, which means that the derivatives have to be equal. Well, the derivative of ax squared plus bx plus 5 is 2ax plus b. And the derivative of, or the slope of y equals 2x minus 3 is 2. And of course, we just have to remember that this is when x is equal to 2. So when x is 2, you get 4a plus, so plugging in 2 here, 4 times a plus b needs to be, this is the slope of the function, this is the slope of the tangent line. They have to be equal. Those are our two equations and two unknowns, and now we can do the elimination method. 4a plus 2b equals -4. 4a plus b equals 2. And we'll go ahead and subtract these two equations. 4a minus 4a, that eliminates the a. 2b minus b, that is b. -4 minus 2 is -6. We can go back and find a. 4a plus, in this case, -6 equals 2. Add 6 to both sides. 4a equals 8, and a equals 2. Here we're just going to use the definition. So we need to look at the limit as h tends to 0 of k of x plus h minus k of x all over h. This is equal to the limit as h tends to 0 of, so k of x plus h, wherever you have an x, you put x plus h. So this is x plus h squared plus 1 minus the original k of x, which is the square root of x squared plus 1, all over h. Okay, so then what we're going to do now is introduce a conjugate, which is going to help us simplify the numerator. As limit as h tends to 0, the square root of x plus h squared plus 1 minus the square root of x squared plus 1 all over h times, and then we'll introduce this thing. It's the square root of x plus h squared plus 1 plus the square root of x squared plus 1. Now I'm not supposed to change things, so this has to be exactly the same thing. X plus h squared plus 1 plus the square root of x squared plus 1. And so then this is going to be equal to the limit as h tends to 0 of, and when you multiply, this is a minus b times a plus b, and that is supposed to be a squared minus b squared, right? So all these square roots cancel, and you're left with x plus h squared plus 1 minus x squared plus 1 all over, there's an h down here, this h right here, times the square root of x plus h squared plus 1 plus the square root of x squared plus 1. This is equal to the limit as h tends to 0. And when you square x plus h squared, you FOIL out and you get x squared plus 2xh plus h squared. The ones cancel, but we'll write this plus 1 minus x squared plus 1. I'm sorry, it's minus 1. You distribute the negative sign. That's important. Minus 1 all over h times the square root of x plus h squared plus 1 plus the square root of x squared plus 1. This is equal to the limit as h tends to 0 of, let's see what cancels here. All right, so the x squareds cancel, the 1's cancel, and you're left with 2xh plus h squared. 2xh plus h squared all over h times the square root of x plus h squared plus 1 plus the square root of x squared plus 1, which is equal to the limit as h tends to 0. Now the numerator has an h in common. We'll factor it out, and this was the whole point because we're about to cancel. It's 2x plus h all over this h times the square root of x plus h squared plus 1 plus the square root of x squared plus 1. These h's cancel, and that leaves us with equal to the limit as h tends to 0 of 2x plus h all over the square root of x plus h squared plus 1 plus the square root of x squared plus 1. And now we can let the limit tend to 0. You get 2x using limit laws, 2x plus 0 over the square root. That h becomes 0 down there. It becomes x squared plus 1 plus another square root of x squared plus 1. It makes 2 of those. This is 2x over 2 square roots of x squared plus 1. The 2's cancel. leaving us with the answer x over the square root of x squared plus 1. That is the derivative